section here that's called proof by contradiction, and this is a bit tricky, so you might need to spend a little bit of time getting your head around this one. So proof by contradiction is very different to other proofs that you've done so far in year one. In year one you did lots of stuff like, this is an even number, so this is an odd number, oh, this is a different odd number, things like that. This comes in handy, but the idea of this proof perhaps does take a little bit of time to get your head around. So what we're going to do, we have kind of 3 steps, is we're going to take some statement, and we'll get to this in a second. We're going to take some statement, and we're going to assume that it's wrong. Okay? We're going to assume sort of like the not case of whatever statement's given to us, and this will make more sense in a moment. And then we're going to work through this not case, and it's going to lead to some result that is ridiculous, that doesn't make sense, like I don't know, 5 equals 4, or some nonsense statement that's a bit more sophisticated. And when we get to this nonsense, then we're going to say, well, if we look at the not case, if we look at our assumption leads us to some stupid result, or some result that doesn't make sense. So, we're going to reject sort of our assumption that it's wrong. Okay? So we're going to reject the assumption that it's wrong. And then we're going to say, well, if our assumption is wrong, then, what they said must be correct. Okay? It's a bit abstract, but just roll with it for now, and it will make more sense later. So let's start with this statement here. And this is not really what the questions will look like, but this is just sort of a way in to thinking about it. So prove that there is no greatest odd integer. In other words, prove that the odd numbers just keep going up and up and up and up. So 1,000,001, 1,000,003, 1,000,005, and so on. So let's follow our steps. Step number 1, assume that the statement is in fact false. So we're going to say something like, assume that there is. Okay, so this is the not case, isn't it? If you say no greatest integer, then the not case of that is that there is a greatest integer. So assume that there is a greatest integer. Yeah, and that's the first part of the proof. So how could you do this? Well, it's as simple as probably you're thinking in your head, which is you can say like, if n is odd, well, what if n is odd? What could you do to make it larger? Well, you could add on 2, couldn't you? Yeah, n plus 2 is sort of a new, larger integer. Okay, this is a bit of a flimsy example, and this is not what the exam questions look like. But just as an idea, okay, the assumption of the opposite case, that there is a greatest integer, if n is odd, okay, if n is odd and the greatest integer. So if we want to make it a bit more robust, if we say that this is the greatest integer, well, the problem with that is we can always add on 2, can't we? Because the number line is continuous. So n plus 2 is the largest integer. Therefore, we reject the assumption, don't we? We reject the assumption that, sorry, I've messed that up a little bit. We reject the assumption there is a greater number, and we accept there is no greatest odd integer. Okay, I'm not going to write the whole thing, yeah, but I'm just sort of trying to touch on the key elements. So there's some assumption, there's some kind of algebra work normally, so let's call that 1, let's call that 2, and then there's a rejecting of your result based on the nonsense and accepting the original case. So let's look at this in a little bit more detail in the next video.